What if everything you thought you knew about the universe was just the tip of the cosmic iceberg? Picture this right now. As you watch this, time is stretching and warping around black holes. Stars are being born in distant galaxies, and entire planets made of diamond are spinning silently in the dark. The universe is stranger than anything we could make up, and today, we're diving into 25 mind-blowing facts about space and time that will leave you questioning reality itself. From a place colder than the void of space to a storm on Jupiter that could swallow Earth whole, we're about to uncover secrets that sound like science fiction, but they're 100% real. So buckle up, because by the end of this journey, you'll never look at the night sky the same way again. Let's get started. Now, let's kick things off with a fact that bends the mind as much as it bends time itself. Imagine you're floating near a black hole, the universe's ultimate gravity well. Thanks to Einstein's theory of relativity, we know that gravity doesn't just pull on objects, it warps time itself. The stronger the gravity, the slower time ticks. So if you were to hover near the edge of a black hole where gravity is unimaginably intense, your watch would crawl compared to someone's back on Earth. Here's the wild part: if you could somehow survive the trip and spend a few minutes near that black hole, decades or even centuries could pass for everyone else. It's like stepping into a sci-fi movie, but this is real physics. The closer you get to a black hole's event horizon, the more extreme the effect becomes, stretching seconds into years for anyone watching from afar. This phenomenon, called time dilation, isn't just a theory. It's been measured right here on Earth with super-precise clocks. Even the satellites in orbit, experiencing slightly weaker gravity, have to adjust their timekeeping to stay in sync with ground-based systems. So next time you feel like life's moving too fast, just remember, near a black hole, you'd have all the time in the world. Now, let's stretch our minds even further with a fact that defies intuition. The universe isn't just expanding, it's doing so faster than light itself. Picture a loaf of raisin bread baking in the oven. As the dough rises, every raisin moves away from the others, not because they're traveling through the dough, but because the dough itself is expanding. Space works the same way. Galaxies aren't zooming through the cosmos like rockets, they're being carried apart by the stretching fabric of space. Here's where it gets wild. While nothing can move through space faster than light, space itself has no speed limit. Hubble's observations revealed that the farther away a galaxy is, the faster it appears to recede from us. Some distant galaxies are racing away so fast that their light will never reach us again, leaving future astronomers with an emptier sky. This relentless expansion means that billions of years from now, galaxies beyond our local group will vanish from view entirely, their light stretched beyond detection. It's a lonely thought, but also a reminder of how bizarre and beautiful our universe truly is. Now, let's take a step back and marvel at just how unimaginably vast our universe really is. Here's a fact that puts everything into perspective. There are more stars in the observable universe than all the grains of sand on every single beach here on Earth. Think about that for a second. Next time you're at the shore, scoop up a handful of sand and try counting those tiny grains. Now imagine doing that for every beach, every desert, every sandy corner of our planet. Even if you could, the number still wouldn't come close to the estimated 1 septillion stars out there. That's a 1 followed by 24 zeros. Wrap your head around that scale for a moment. Our Milky Way alone holds hundreds of billions of stars, and it's just one of trillions of galaxies scattered across the cosmos. Each of those stars could host its own planets, its own possibilities. It's humbling, isn't it? The next time you look up at the night sky, remember those pinpricks of light are just the tiniest glimpse of what's really out there. The universe isn't just big, it's beyond anything our everyday experiences can prepare us for. Now, let's turn our attention to one of the most bizarre quirks in our solar system, Venus, the planet where time itself seems to play by different rules. Here's something that will bend your mind. A single day on Venus lasts longer than its entire year. That's right, while it takes Venus just 225 Earth days to complete one trip around the Sun, the planet spins so slowly on its axis that a full rotation takes 243 Earth days. Imagine celebrating your birthday before you've even seen a single sunrise and sunset. But Venus doesn't stop at just being sluggish, it's also a rebel. Unlike most planets which spin counterclockwise, Venus rotates clockwise in what's called a retrograde spin. Scientists think this backward twirl might be the result of a colossal collision billions of years ago, or the gravitational tug of war with its thick, suffocating atmosphere. And speaking of that atmosphere, it's a crushing blanket of carbon dioxide, with pressures 90 times heavier than Earth's and temperatures hot enough to melt lead. This dense shroud traps heat in a runaway greenhouse effect, making Venus the solar system's ultimate pressure cooker. So why does this matter? Venus teaches us how wildly different planetary environments can be, even in our own cosmic backyard. Its extremes challenge our assumptions and remind us that the universe loves throwing curveballs. Next time you hear someone call Earth's twin, remember Venus is more like Earth's twisted mirror image, where everything, even time, works in reverse. Now let's shift our gaze from the scorching chaos of Venus to something even more extreme: neutron stars, the universe's ultimate cosmic pressure cookers. These mind-bending remnants of supernova explosions pack so much mass into such a tiny space that just a single teaspoon of their material would weigh a staggering 1 billion tons here on Earth. To put that into perspective, imagine crushing the entire Mount Everest down to the size of a sugar cube. That's the level of density we're talking about. Neutron stars are born from the violent deaths of massive stars. When a star several times heavier than our Sun runs out of fuel, it collapses under its own gravity in a cataclysmic explosion called a supernova. What's left behind is a core so dense that protons and electrons are squeezed together, forming neutrons, hence the name. The result, a city-sized object with a mass greater than our Sun, spinning at dizzying speeds and sporting magnetic fields trillions of times stronger than Earth. But here's where it gets even wilder. The gravity on a neutron star's surface is so intense that if you dropped an object from just 1 meter above, it would hit the surface at around 7 million kilometers per hour. And those magnetic fields, they're powerful enough to distort atoms into thin needles from thousands of kilometers away. Neutron stars don't just defy expectations, they rewrite the rules of physics, showing us just how strange and awe-inspiring the universe can be when pushed to its limits. Now, let's turn our attention from the crushing extremes of neutron stars to something happening right in our cosmic backyard. Our very own moon is slowly but surely drifting away from Earth. Every single year, the moon moves about 3.8 centimeters farther into space, and while that might not sound like much over time, it adds up in ways that will reshape our planet's future. This gradual escape is all thanks to tidal forces, the same gravitational tug of war that gives us ocean tides. As the moon's gravity pulls on Earth, it stretches our planet slightly, creating a bulge of water. But because Earth rotates faster than the moon orbits, this bulge actually gets dragged a little ahead of the moon. That extra mass then pulls the moon forward, giving it a tiny energy boost that pushes it into a higher orbit. So what does this mean for us in the long run? Well, as the moon inches away, Earth's rotation will slow down, making our days longer. Right now, a day is about 24 hours, but in a few 100 million years, it could stretch to 25 or even 30 hours. And eclipses, they'll become a thing of the past. The moon will appear smaller in the sky, eventually reaching a point where it can no longer perfectly block the sun during a solar eclipse. It's a gentle reminder that even the most familiar parts of our universe are in constant motion. quietly shaping the future in ways we're only beginning to understand. Now, let's journey from the familiar dance of the Moon and Earth to one of the most baffling mysteries in the cosmos, the Boötes Void. Imagine a region of space so vast it could fit thousands of galaxies, yet it's almost completely empty. Stretching an astonishing 330 million light-years across, this cosmic desert, known as the Boötes Void, defies everything we know about how the universe should look. Most of the universe is like a bustling city packed with galaxies, stars, and planets, but the Boötes Void, it's more like a ghost town. Astronomers have found only a handful of galaxies in this enormous space, leaving scientists scratching their heads. How could something this big be so empty? One theory suggests it might be the result of quantum fluctuations in the early universe, tiny ripples in space-time that left some regions oddly barren. Others, well, they let their imaginations run wild. Could advanced civilizations have somehow cleared out this area? It's a fun idea, but there's no evidence to back it up. What we do know is that voids like this challenge our understanding of cosmic structure, forcing us to rethink how matter spreads across the universe. So next time you gaze up at the night sky, remember, even in the vastness of space, emptiness can be just as puzzling as the stars. Now, let's shift our gaze from the eerie emptiness of the Boötes Void to the staggering scale of our own cosmic home, the Milky Way. Picture this: if you could hitch a ride on a beam of light, it would still take you 100,000 years just to travel from one side of our galaxy to the other. That's how mind-bogglingly vast the Milky Way is. To put that into perspective, imagine the fastest human-made spacecraft, like NASA Parker Solar Probe, which can reach speeds of up to 430,000 miles per hour. Even at that blistering pace, it would take tens of millions of years to cross the same distance. Light, on the other hand, zooms through space at 670 million miles per hour, yet it's still dwarfed by the sheer size of our galaxy. Here's another way to think about it. If the Milky Way were shrunk down to the size of a football field, our entire solar system would be just a tiny speck, smaller than a grain of sand tucked away in one corner. Earth, it wouldn't even be visible. This scale reminds us just how small we are in the grand scheme of things. And here's something even wilder. The Milky Way isn't just big, it's also dynamic. Stars, gas, and dust swirl around its center, creating a cosmic dance that takes 250 million years to complete just one orbit. That means the last time our solar system was in this position, dinosaurs were just beginning to rule the Earth. So the next time you look up at the night sky, remember, every star you see is part of this colossal, spinning masterpiece, and light itself is just a slow traveler in the grand expanse of our galaxy. Now, let's turn our attention from the vastness of the Milky Way to something a little closer to home: Saturn's dazzling rings. Believe it or not, those iconic rings are actually younger than the dinosaurs that once roamed Earth. Scientists estimate they formed just 100 to 200 million years ago, which means they weren't even around when T-Rex was stomping through prehistoric forests. So how did these rings come to be? One leading theory suggests a moon or a comet got too close to Saturn and was torn apart by the planet's immense gravity. Imagine a cosmic wrecking ball swinging too close and shattering into countless icy fragments, eventually spreading out into the stunning rings we see today. Another possibility is that a collision between two moons sent debris swirling into orbit, creating the rings over time. What's even more mind-blowing is that Saturn's rings might not be permanent. They're slowly losing material, raining down onto the planet as icy particles. Some researchers think they could disappear entirely in another few 100 million years, a blink of an eye in cosmic terms. So while they look eternal from our vantage point, they're actually more like a temporary cosmic art installation. Next time you gaze at Saturn through a telescope, remember, you're looking at a relatively recent addition to our solar system, a fleeting masterpiece that future civilizations might never get to see. Now, here's something that might surprise you. The coldest place in the entire universe isn't some distant, frozen corner of space. It's right here on Earth, in laboratories where scientists create something called a Bose-Einstein condensate. These bizarre states of matter can reach temperatures just a hair above absolute zero, the theoretical point where all motion stops. To put that in perspective, even the cosmic background radiation, the faint afterglow of the Big Bang, is warmer than these lab-made supercold conditions. So how do scientists achieve such extreme cold? They start by trapping atoms, often rubidium or sodium, in magnetic fields and then using lasers to slow them down, effectively draining their energy. As the atoms lose heat, they enter a strange quantum state where they behave more like waves than particles, merging into a single, ghostly superatom. This is the Bose-Einstein condensate, a place where the rules of everyday physics break down and quantum weirdness takes over. What's truly mind-bending is that these ultra-cold experiments aren't just for show. They help us test the limits of quantum mechanics, simulate black hole conditions, and even explore the nature of dark energy. And while space itself is frigid, it's never as cold as what we've created in these labs. So next time you shiver on a winter day, remember Earth holds the record for the deepest chill in the cosmos. Now, let's shift our gaze to something that might seem impossible at first glance: the sheer amount of space between Earth and the Moon. Believe it or not, you could fit every single planet in our solar system in that gap, with room to spare. The average distance between Earth and the Moon is about 384,400 kilometers. That might sound like a lot, but here's the kicker. If you lined up the diameters of all the other planets from Mercury to Neptune, they'd add up to less than that distance. Picture this: Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, all of them stacked side by side. Even with Jupiter's massive size and Saturn's iconic rings, their combined width still falls short of the Earth-Moon gap. It's a stunning reminder of just how vast space really is, even in our own cosmic backyard. And here's another twist: this isn't just a fun fact. It puts into perspective how much empty space exists in our solar system. Planets might seem close when we see them in diagrams, but in reality, they're tiny dots floating in an unimaginably huge void. So next time you look up at the Moon, remember, there's enough space out there to fit an entire planetary parade. Now let's step into a realm where silence reigns supreme: outer space. Unlike the explosive soundtracks of sci-fi movies, space is utterly silent. Why? Because sound needs a medium to travel, like air or water, and space is a near-perfect vacuum. No air means no sound waves, so even the most cataclysmic cosmic events, supernovas, colliding galaxies, or black holes devouring stars, happen in complete silence. Think about your favorite space battles in films. Those roaring engines and laser blasts, pure Hollywood magic. In reality, astronauts floating in the void wouldn't hear a thing, no matter how close they were to a supernova. But don't worry, they're not cut off from communication. Astronauts rely on radio waves, which don't need air to travel. Their headsets pick up these signals, turning them into the voices we hear during missions. It's a strange thought, isn't it? The universe is filled with unimaginable energy and motion, yet it unfolds in absolute quiet. Next time you watch a space movie, remember, the real soundtrack of the cosmos is the silence between the stars. Now imagine a world so dazzling it puts any jewelry store to shame: a planet literally made of diamond. Meet 55 Cancri e, an exoplanet orbiting a star 40 light-years away, where the conditions are so extreme they turn carbon into sparkling diamond. This isn't science fiction. Scientists estimate that about a third of this planet's mass could be crystalline diamond, thanks to crushing pressures and scorching temperatures that rearrange carbon atoms into the hardest natural material known. How do we know this? Telescopes analyzed the planet's atmosphere and found an unusually high amount of carbon. Combined with its density and proximity to its star, researchers concluded that beneath layers of graphite, the core likely solidified into diamond. Picture a world where mountains might gleam like gemstones, though you'd never want to visit. Surface temperatures hover around 4,000 degrees Fahrenheit, hot enough to melt steel. What's even wilder, 55 Cancri E isn't alone. Other carbon-rich exoplanets might hide similar treasures, rewriting what we thought possible in the cosmos. So next time you admire a diamond ring, remember there's a whole planet out there that puts Earth's jewels to shame. And speaking of cosmic riches, wait until you hear about the giant cloud in space filled with enough alcohol to supply every bar in the galaxy. But that's a story for another fact. Now, let's shift our gaze to the heart of our solar system, where the sun reigns supreme in a way that's almost hard to wrap your head around. Picture this: if you gathered every planet, moon, asteroid, and speck of dust in our solar system, the sun would still account for a staggering 99.8% of all that mass. That's right, nearly everything in our cosmic neighborhood is just the sun, with the rest being little more than scattered crumbs. To put it in perspective, imagine a basketball placed at the center of a room. Now sprinkle a few grains of sand around it, some smaller, some slightly larger. That basketball, that's the sun. Those tiny grains, those are the planets, with Jupiter being the largest speck, yet still just a fraction of the sun's colossal size. Even Jupiter, the heavyweight champion of the planets, only makes up about a third of that remaining 0.2%. The rest of the planets, including Earth, are barely a rounding error in comparison. This overwhelming dominance isn't just a fun fact. It's the reason the solar system works the way it does. The sun's gravity keeps every planet locked in orbit, and its energy fuels life on Earth. Without that 99.8%, there'd be no light, no heat, and no us. So next time you feel small under the vastness of space, remember, even in our own cosmic backyard, the sun reminds us just how much weight it pulls. And speaking of cosmic heavyweights, wait until you hear about the icy secrets hiding in the shadows of Mercury's craters. But that's a story for another fact. Now let's zoom in on Mercury, the smallest planet in our solar system, where something truly bizarre is hiding in plain sight, or rather in permanent shadow. You'd think a planet that's practically next door to the sun, with daytime temperatures soaring to a blistering 800 degrees Fahrenheit, would be the last place to find ice. But Mercury has a sneaky trick up its sleeve. Deep within craters at its poles, where sunlight never reaches, pockets of water ice have been lurking for who knows how long. These craters are like cosmic freezers, their floors shrouded in eternal darkness. While the rest of Mercury bakes under the sun's relentless glare, these shadowy pits stay colder than the coldest winter night on Earth, preserving ice that might have been there for billions of years. But here's the real head-scratcher: how did the ice get there in the first place? One leading theory points to asteroids and comets, cosmic delivery trucks that crashed into Mercury long ago, depositing water in its polar traps. Over time, the ice stayed put, shielded from the sun's heat by crater walls acting like natural insulation. It's a reminder that even in the most extreme environments, nature finds a way to surprise us. And if Mercury, a planet where you could literally fry an egg on the surface, can hold onto ice, what other secrets might be hiding in plain sight across the cosmos? But that's a question for another day, because next up, we're venturing to the edge of the solar system, where time itself stretches to unimaginable length. Now, let's journey to the outer reaches of our solar system, where time moves at a pace that would make even the most patient among us pause. Pluto, that tiny, distant world stripped of its planet status but never its intrigue, operates on a clock unlike anything we're used to. A single year on Pluto, one full trip around the sun, lasts a staggering 248 Earth years. That's longer than the United States has existed as a nation. Pluto's orbit isn't just long, it's wildly elliptical, swinging it closer to the sun than Neptune at times, then flinging it out into the frigid depths of the Kuiper belt. This extreme path creates seasons that stretch for decades, with temperatures plunging to nearly 400 degrees below zero. Imagine winter lasting longer than a human lifetime snowfall that wouldn't stop for 50 years. But Pluto isn't just a frozen rock. Thanks to NASA's New Horizons mission, we've glimpsed its heart literally. A massive, heart-shaped glacier named Tombaugh Regio sprawls across its surface, made of nitrogen ice that shifts like a slow-motion ocean. The mission also revealed a wispy atmosphere that freezes and falls as snow when Pluto retreats from the sun, only to puff back up as it nears again. This tiny world, once thought barren, is alive with geological drama, ice mountains, shifting plains, and an atmosphere that breathes over centuries. It's a reminder that even in the solar system's quietest corners, time weaves stories too grand to rush. And speaking of grand, our next stop takes us to a place where the universe itself might be playing the ultimate trick on our senses. But before we get too lost in Pluto's icy mysteries, let's take a detour to one of the universe's most bizarre sensory surprises. Picture this: floating through the vast emptiness of space, you suddenly catch a whiff of something oddly familiar: raspberries and rum. No, you haven't stumbled upon an interstellar cocktail party. Scientists discovered that a molecule called ethyl formate, found in giant clouds of gas near the center of our galaxy, carries this exact sweet, boozy aroma. It's the same compound that gives raspberries their fruity punch and rum its distinctive kick. Now, before you start dreaming of cosmic bakeries or space-age distilleries, here's the catch: those interstellar clouds are freezing, radiation-filled voids, not exactly prime real estate for a snack break. Astronauts won't be sipping space mojitos anytime soon. But this discovery is more than just a quirky fun fact. Ethyl formate is part of a growing list of complex organic molecules found in space, hinting at the building blocks of life scattered across the cosmos. So while we might not get to taste the universe's weird cocktail, it's thrilling to think that the ingredients for life, or at least a decent dessert, might be floating out there waiting to be discovered. And speaking of discoveries, our next fact takes us from the aromatic to the absolutely colossal. Now, shifting our gaze from the sweet mysteries of space to the swirling storms of Jupiter, let's talk about one of the solar system's most iconic features: the Great Red Spot. This massive storm, big enough to swallow Earth whole, has been raging for centuries, but here's the twist: it's shrinking. Back in the 1800s, this crimson tempest stretched a staggering 40,000 kilometers across, wide enough to fit 3 Earths side by side. Today, it's down to just 16,000 kilometers, and scientists are locked in a debate. Will it vanish entirely or find a way to stabilize? Some researchers think the storm's days are numbered, slowly losing energy as it's squeezed by competing winds or chewed up by smaller vortices. Others argue it might hit a tipping point and hold steady, like a spinning top finding its balance. What's wild is that even as it shrinks, the storm's winds are speeding up, whipping around at over 400 kilometers per hour. It's like watching a figure skater pull their arms in to spin faster, only on a planetary scale. Whether the Great Red Spot fades away or sticks around, its story reminds us that even the mightiest forces in the universe aren't permanent. And as we ponder Jupiter's stormy fate, our next fact takes us to a place where time itself bends to the rules of relativity. Now, let's take a leap from Jupiter's storms to something even more mind-bending: time travel. And here's the wild part: we're already doing it. Thanks to Einstein's theory of relativity, astronauts on the International Space Station are technically time travelers, aging just a tiny bit slower than the rest of us on Earth. It's called time dilation, and it happens because the faster you move, the slower time ticks for you compared to someone standing still. For astronauts orbiting at around 28,000 kilometers per hour, this means they come home about 0.005 seconds younger than they'd be if they'd stayed on the ground for a 6-month mission. That might not sound like much, but it adds up over longer trips. Imagine a journey to a distant star at near light speed. and you could return to find decades or even centuries have passed on Earth. Scientists are already dreaming up faster spacecraft like nuclear-powered or light-sail designs that could push this effect even further. Picture this, a crewed mission to Proxima Centauri, our nearest star neighbor, traveling at 90% the speed of light. By the time they return, everyone they knew might be gone, but they'd only have aged a few years. It's not quite the flashy time machines of sci-fi, but it's real physics proof that the universe has its own rules for bending time. And speaking of cosmic rules, our next fact takes us to a place where space itself smells surprisingly familiar. Now, let's shift from the mind-bending physics of time travel to something equally astonishing, space's very own interstellar bar. Deep in the constellation Sagittarius, there's a massive gas cloud called Sagittarius B2, and it's floating with enough alcohol to fill billions of liquor bottles. That's right, billions of liters of ethanol, the same stuff in your favorite drink, swirling around in the void of space. But before you start picturing cosmic happy hours, here's the catch: this cloud isn't just booze. It's a cosmic cocktail of complex molecules, including sugars and even amino acids, the building blocks of life. Scientists believe these molecules form on the icy surfaces of dust grains, where atoms link up in the cold, sparse environment of space. Over time, radiation and chemical reactions stitch them into bigger, more intricate structures. What's truly wild is that these space-borne molecules might have hitched rides on comets or asteroids, eventually seeding young planets like Earth with the ingredients for life. So while Sagittarius B2 won't be serving drinks anytime soon, it's a reminder that the universe is far more creative and maybe even a little mischievous than we ever imagined. And speaking of cosmic surprises, our next fact takes us to a place where the moon itself has a case of the shakes. Here's the script section for fact 21, seamlessly continuing from the previous content. Now, let's turn our attention to something closer to home, well, relatively speaking. You might think earthquakes are strictly an earthly phenomenon, but our moon has its own version, moonquakes, and no, it's not just the lunar surface settling into place. These tremors are caused by two main forces. First, Earth's gravity tugs on the moon, creating tidal stresses that flex its crust, just like how the moon's pull gives us ocean tides. Second, the moon's surface temperature swings wildly, from scorching 260 degrees Fahrenheit in sunlight to freezing minus 280 degrees in shadow. That extreme heating and cooling makes the ground contract and expand, triggering cracks and shifts. But here's where moonquakes get weird compared to Earth. On our planet, quakes usually last seconds or minutes. Moonquakes, they can go on for hours. Thanks to the Apollo missions, we know this firsthand. Astronauts left seismometers on the moon, and the data revealed some quakes reaching up to 5.5 on the Richter scale, strong enough to rattle dishes off a shelf. Yet without air or water to soften the blows, the moon's tremors echo like a bell, lingering far longer than they would hear. So next time you gaze up at that serene, silent orb, remember, beneath its calm exterior, the moon is still shaking things up. And speaking of celestial surprises, our next fact takes us to a star whose light has been racing toward us since the age of dinosaurs. And now, let's zoom in on something we often take for granted: the sunlight warming your skin right now. That golden beam didn't just appear instantly. In fact, it raced across space for a full 8 minutes before reaching you. Here's why that's mind-blowing. Light is the fastest thing in the universe, traveling at an astonishing 186,000 miles per second. Yet, even at that speed, crossing the 93 million miles between the Sun and Earth takes time. Picture this: if the Sun suddenly disappeared, poof, gone, we wouldn't know for those same 8 minutes. Earth would keep orbiting nothingness, blissfully unaware, while sunlight already on its way would continue to brighten our skies. It's a haunting reminder of how even the speed of light has its limits in the vastness of space. This delay isn't just a cosmic quirk, it shapes how we explore the universe. When astronomers peer at distant stars, they're essentially looking into the past. The closest star system, Alpha Centauri, its light takes over 4 years to reach us. So every time you glance up at the night sky, you're not just seeing stars, you're witnessing ancient history written in photons. And that brings us to our next fact, where we'll encounter a volcano so massive it dwarfs anything on Earth now. Let's turn our attention to a towering giant that makes even Earth's mightiest mountains look like mere hills. On Mars, Olympus Mons isn't just a volcano. It's a record-breaking behemoth standing 3 times taller than Mount Everest. Picture a mountain so vast that its base could cover the entire state of Arizona, with peaks scraping the thin Martian sky at 16 miles high. What makes this possible? Unlike Earth, Mars doesn't have shifting tectonic plates. Here, our volcanoes eventually drift away from their magma sources, limiting their growth. But on Mars, the crust stays put, letting a single volcanic hotspot erupt continuously for billions of years. The result? A mountain so massive it would take an astronaut over 6 hours to drive from base to summit, if roads existed on the red planet. And here's the kicker, Olympus Mons isn't just tall, it's wide. Its slopes are so gentle you might not even realize you're climbing until you're halfway to the top. This gentle incline hints at the volcano's secret. Its lava flows were likely slow and runny, oozing across the landscape like syrup rather than exploding violently. It's a frozen testament to Mars's fiery past, and a reminder that even in our solar system's quiet corners, nature still holds the title for grandest architect. Up next, we'll witness a cosmic collision billions of years in the making, one that will reshape our galaxy forever. Now, let's zoom out from our own cosmic backyard and witness a dance of galaxies on an unimaginable scale. The Milky Way and Andromeda, 2 titans of the local universe, are on a collision course, but don't panic. This isn't a cosmic car crash. In fact, it's more like a graceful merger unfolding over 4 billion years. Here's why it's so mind-bending. Andromeda is hurtling toward us at 250,000 miles per hour, but the vast emptiness of space means stars will simply glide past one another like ships in the night. The distances between them are so enormous that direct collisions are almost impossible. Instead, gravity will weave the 2 galaxies into a new, larger galaxy dubbed Milkdromeda, with a stunning, elongated shape. What's even wilder, this merger will rewrite the night sky. As the galaxies intertwine, their spiral arms will stretch and distort, scattering stars into dazzling new patterns. Andromeda, which today is a faint smudge in the sky, will grow larger and brighter until it dominates the view. Eventually, the 2 supermassive black holes at their cores will spiral together, unleashing gravitational waves. But that's a story for another cosmic era. So while we won't be around to see this galactic tango, it's a humbling reminder that even the universe is in constant, beautiful motion. Up next, we'll tackle one of the most radical ideas in physics, the possibility that everything we see might just be a cosmic illusion. Now, let's stretch our minds even further with one of the most radical ideas in modern physics. What if our entire universe is nothing more than an illusion? That's the jaw-dropping premise of the holographic principle, a theory suggesting that everything we perceive in 3 dimensions, stars, planets, even you and me, might actually be encoded on a distant 2-dimensional surface like a cosmic projector screen. Think of it this way, just as a hologram on your credit card creates the illusion of depth from a flat image, the universe could be a vast, immersive hologram. This idea emerged from studying black holes, where physicists discovered something bizarre. The information swallowed by a black hole isn't lost forever. Instead, it's somehow preserved on its event horizon, the point of no return. That discovery led to a wild question. If a black hole's 3D interior can be described by data on its 2D surface, could the same be true for the entire cosmos? The implications are staggering. It would mean reality as we know it is a kind of cosmic trick, with the true source code of the universe existing on a boundary we can't see. Some scientists even compare it to living inside a video game where the graphics feel real, but the underlying mechanics are far simpler. Of course, this isn't just sci-fi speculation. It's a hot topic in cutting-edge physics, with experiments like the holometer at Fermilab trying to detect quantum fuzziness that could hint at a holographic universe. While the theory is far from proven, it challenges everything we assume about space, time, and existence itself. So next time you gaze at the stars, remember, they might not just be distant suns, but pixels in the grandest illusion of all. And with that, we've reached the end of our cosmic journey, but don't go just yet. Stick around as we recap the most mind-bending facts that left even us questioning reality. And just like that, we've traveled through the mind-bending wonders of space and time together. From the way black holes stretch time like taffy to the mind-blowing idea of a diamond planet twice the size of Earth, the universe never fails to leave us in awe. Who could forget the cosmic cocktail cloud smelling like raspberries, or the fact that all planets could squeeze between Earth and the Moon? These aren't just fun facts, they're reminders of how strange, beautiful, and utterly mysterious our cosmos truly is. Now we want to hear from you. Which fact blew your mind the most? Drop your favorite in the comments below, and don't forget to hit that subscribe button so you never miss out on more cosmic adventures. Ring the notification bell to join us as we keep unraveling the universe's biggest mysteries, one mind-expanding discovery at a time. As we wrap up, think about this. Every time we gaze at the stars, we're not just looking at distant lights, we're peering into a story billions of years in the making. From the tiniest quantum quirks to the vast dance of galaxies, humanity's quest to understand space and time is far from over. And who knows, maybe the next groundbreaking discovery will be yours. Until then, keep wondering, keep exploring, and remember, the universe is always stranger than we can imagine. Thanks for joining us on this journey through the cosmos.